A very warm welcome to all. Very good afternoon to all our guests joining in from the UK. A good evening to all our guests joining in from India and South Asia. And a very good morning to all our guests joining in from the US and South America. Today is the ninth seminar in the second edition of this seminar series, which is on the topic the digital future for business and society, emerging perspectives on AI, blockchain, and IoT. This seminar series has been hosted jointly by Professor Yogesh Dwivedi, who is a professor of digital marketing and innovation, founding director of the Emerging Markets Research Center, and co-director of research, School of Management, Swansea University, Wales, UK. Our co-host for this seminar series is Professor Ramakrishnan Raman, director at SIBM Pune, Dean, Faculty of Management, Symbiosis International University, and Director of Strategy and Development, Symbiosis. Our entire seminar series is jointly supported by the Center for Technology, Innovation, Management and Enterprise, TIME, the University of Kent, UK, Digital Marketing and Analytics, SIG, Academy of Marketing, Grenoble IAE Graduate School of Management, a Grenoble INP School of the University of Grenoble, Alps, the e-business and e-government SIG, British Academy of Management, and the UK Academy for Information Systems, UK AIS. To tell you something about the seminar series itself, emerging technologies such as artificial intelligence, blockchain, and Internet of Things undoubtedly offer a transformative potential for the augmentation and potential replacement of human tasks and activities within a wide range of industrial, intellectual, and social applications. The pace of change for this new AI technological age is staggering, with new breakthroughs in algorithmic machine learning and autonomous decision making, coupled with developments related to blockchain and IoT, engendering new opportunities for continued innovation. The impact of AI and other emerging technologies could be significant, with industries and sectors ranging from agriculture, finance, healthcare, manufacturing, retail, supply chain, logistics, and utilities, all potentially being disrupted by the onset of these technologies. The seminar series on the digital future for business and society, emerging perspectives on AI, blockchain, and IoT, will present various perspectives from a number of leading expert speakers to highlight these opportunities and challenges posed by the rapid emergence of these transformative technologies. Today, we have an eminent thought leader with us, Dr. Dhaval Thakker from the University of Bradford, UK. He will share his thoughts on the area of artificial intelligence, IoT, and citizen science to scale up air quality monitoring. To tell you something about Dr. Dhaval Thakker, he is an associate professor of explainable AI and IoT at the University of Bradford. He is currently the director of postgraduate research in the Faculty of Engineering and Informatics and leads the Internet of Things Innovation Lab. Dhaval has over 17 years of working experience in the European Union and industrial projects, researching and delivering innovative solutions. He's also a part of the university's Research Practice Innovation Group, led by the Pro Vice Chancellor Research and Knowledge Transfer to help shape the university's research and innovation strategy. His broad area of research interest and expertise is interdisciplinary, focusing on the use of AI and the Internet of Things technologies for the betterment of society. His current and evolving research interests include exploring the role of AI and IoT technologies in the context of smart cities, digital health, and the circular economy. To date, he has been successful as a principal and co-investigator in over £4 million worth of R&I projects funded by national and international funding bodies and commercial organizations. Some of the notable funders have been the European Commission, Innovate UK, HFCE, and GCRF, focusing on research projects addressing societal challenges surrounding themes such as smart cities, air quality monitoring, flood monitoring, children's health, Industry 4.0, smart factories, and archaeological and drone-based surveys in war-torn areas. Dr. Dhaval, it's a pleasure to have you with us here today. Over to you now, sir.
Thank you. Let me start sharing my screen. I can can see already, you can hear me. You can see my screen?
Yes.
Okay, perfect. Thank you. All right, so all right, before I start off, I just want to thank Symbiosis Pune and Swansea University, in particular, Professor Yogesh Dwivedi and Dr. Gopalkrishnan for inviting me to deliver this talk. I'm happy to have everybody here virtually. Welcome. I hope you find the talk and what is being covered interesting. So this work, so as I think quite a lot of introduction is provided, I'm an associate professor at the University of Bradford. The work I'm presenting is done as part of two EC-funded projects. One is SCORE and the other is Life Critical. And I'll talk about those projects in a moment. But I also want to say that this work is done in close collaboration with partners from the UK, Bradford City Council, and also from Sweden, which is Nuremberg Science Park, and Swedish Environment Institute, which is IVL. So this is the brief outline of my talk. I'm going to start with introducing my research group because we do a lot more in addition to air quality work as well. Then I'm going to introduce these two projects I've talked about. I'll provide a context of air pollution that's worldwide, but also our local context in terms of Bradford as well. And then I'm going to focus on the main topic of this talk, scaling up air quality monitoring, why that's required, and how citizen science, low-cost sensors, IoT sensors, and AI can help with that. What is the bigger picture? And I'll try to wrap that up all in 40 minutes. If the time permits, I'll talk about the two trials we are leading in terms of indoor air quality monitoring as well, time permitting. So this is, so I lead, as Dr. Gopalkrishnan said, I lead the IoT Innovation Lab at the University of Bradford. So this is my small group. These are the key researchers as part of the group. This is the website of the group, but we have expertise in Internet of Things, artificial intelligence, especially explainable AI, data science, and the kind of domains and the projects we do are under smart cities with a lot of focus on air quality and flood monitoring, digital health, and circular economy. These are the members of the group. In fact, today the work I'm presenting is led by Ramiz and Reena, which some of this is part of their PhD as well, and which were supported by Dr. Bhupesh Mishra as well. But these are the other members of the group as well, working on all of them have topics related to IoT, environment / air quality, but also some of them looking at security and circular economy as well. So in terms of the first project, which is SCORE, stands for Smart Cities and Open Data Reuse. This is a project which is coming to end at the end of the August. So there will be 4-year project. And there are 9 cities partner and 3 universities as partners in this project, including us. And the aim of this project is to develop smart cities solutions. It's quite an applied project with themes of mobility, water, and environment. And the work I'm presenting here fits into that third theme. The second project this work relates to is called Life Critical, where critical stands for climate resilience through involvement of local citizens. So there is a lot of focus. This is a project which is part of LIFE program of EU's funding instrument, where the focus is environment and climate action. And there is a lot of focus on the parks and involvement of the citizens for climate adaptation and climate resilience. And there are 2 city partners into this. One is Dordrecht from Netherlands. The other is Bradford from the UK. And we kind of are supporting Bradford City Council with some of the work they do in this project. But also there is a plan to do replication of what happens in Dordrecht and Bradford into 2 other cities such as Ghent and Bergen as part of this project as well. So work I'm presenting is kind of fits into these two projects. Obviously, you know, I want to start with talking about climate change. We all are aware of the impact of climate change, especially in global warming. And as you can see from this slide at the top left corner from UK's Met Office, you know, temperatures are rising. In the UK, we had the 5 warmest years post 2006. So there are a lot of rates there. Also across the world, there is more extreme events happening more frequently. That might be, you know, drought, wildfire, whether it's flood or storms. We all have seen this. And in UK, I think we expect to see, you know, even going forward, more warmer and wetter winters, hotter and drier summers, more frequent and intense weather patterns. And obviously, the air quality is, you know, when you talk about air pollution, it has a complex relationship with climate change. Things like black carbon or ozone trap the heat in the atmosphere. Hence, they contribute to warming. While on the other side, if you look to take something like sulfur dioxide, it has cooling effect on climate. And they both share the lot of emission sources, but also kind of effect they have on public health as well in terms of mortality and morbidity as well. We know that, you know, air pollution is the silent killer. This is from WHO, World Health Organization, where they've talked about that there are 7 million deaths which are due to exposure from both outdoor and indoor, which is household air pollution. I'll talk about the health impact later on, but you can see the figures are staggering. You know, about 2 million in Southeast Asia region to Western Pacific region, but also, you know, 500,000 in European region as well. Talking about the health impact, you have short-term effects, especially people with, you know, this is quite bad for people with respiratory conditions such as asthma. And in short term, it can, you know, it can increase the episode of, you know, asthma attacks and so on, and hospital admissions, and also in worst case mortality as well. In terms of long-term effects, you know, stroke, lung cancer, respiratory conditions, cardiovascular disease, you know, long-term continuous and constant exposure to high level of air pollution can lead to that, and also can lead to reduced life expectancy as well. So when we talk about air pollution, especially with the kind of work we do, there are various ways to measure air pollution. We talk about particulate matter pollution, short for PM, particulate matter. It's a very, in my opinion, it's a very crude but very effective way of monitoring the pollution in the air. Basically, what it looks for is the size of particles, you know, complex mixture of small particles and liquid droplets. And it just looks for the diameter of the particles. So you could have what we call the particles diameter less than 2.5 microns in diameter. That's PM 2.5, and PM10, which is less than 10 microns in diameter. So these particles are quite tiny, and you can see the context in terms of human hair. It's 50 to 70 microns. So these are very, very tiny particles, this PM 2.5 and PM10. If you inhale that, it goes through the bloodstream to your lungs, and as we discussed, you know, long-term exposure to it is detrimental to health. And obviously, the emission sources are, you know, as expected, any sort of burning, whether that's from plants, wood stoves, industrial sources, or combustion from, you know, cars, trucks, or diesel engines. And obviously, you know, this problem is known for a while, and a lot of efforts from the governments all around the world are happening to reduce the air pollution. The WHO, World Health Organization, have its own guidelines. for how much should be there. So for example, for PM 2.5, the annual mean is 10 microgram per meter cube of air. And when it comes to different governments, sometimes they are a bit more relaxed, as is the case with UK than WHO is. I suspect that the baseline where they want to go, and also some of the practicalities comes into the play. So that's why, the government targets are generally a little bit more relaxed than WHO, but there are targets. For example, as I said, PM 2.5 target in UK is annual mean of 20 microgram per meter cube of air. And there are similar targets set by European Environment Agency as well for PM 2.5, PM 10, but all other pollutants as well. And I think that is as we discussed, the infographics I had from WHO kind of laid bare, number of deaths attributed to air pollution. And we have a considerable health challenge, all over the world, but also Europe, EU as well. So if you look at the EU's own, guideline and the limits, you could say that in terms of, the population, about 7 to probably 25% are exposed to air pollution, which is above EU standards. But if you look at WHO guideline, which mainly focuses on the health and what is good for health rather than what is practical, in my opinion, you're looking at, EU population exposed to air pollution would be anywhere from 7% to 85%, for example, for PM 2.5. So there is a considerable health challenge here. So coming back to the local context and what we've been working on, so the local context is Bradford. If you're not familiar, if you're outside from the UK, or even if you're from the UK, if you're not familiar with Bradford, it's a city in West Yorkshire. It's nearby Manchester, about 40-45 miles, and it's about 10-15 miles from another city, which is Leeds. It's a metropolitan district, and it has a population of over 500,000, which is high for the UK. It's ranked 7th in terms of the district's population, and the population is quite diverse ethnicity-wise, as you can see it from here. So why Bradford has a problem with air pollution, and what Bradford is doing is trying to bring interventions such as clean air zone. I'll explain what clean air zone is in a second. But UK has its own annual limits which are enshrined into regulation, and one of them is the air quality standards regulation 2010. Which puts a limit for nitrogen dioxide to be 40 microgram per meter cube, which is the legal limit for annual mean. And what Bradford Council has observed over the number of years, is that there are localized areas, as mentioned in the first bullet point, where the pollution is consistently above the legal limit in terms of NO2 levels. And this is shown by this modeling in the red color as well. There was a hope that with the lockdown, things will improve after the lockdown. Obviously, during the 2 lockdowns or 3 lockdowns we had, things improved, but then they've noticed that traffic flows are now higher than even before. And still, there are localized areas which are still above the legal limit as well. And obviously there is a health impact of air pollution, and Bradford is a special case. I'll come to that, why that is the case in the next slide. So this is one of the roads, very busy road in Bradford, which, as you can see here, air pollution level right here is 30% above the legal limit. What they have done is Bradford is one of the other 20 plus councils or cities which are asked to bring in interventions such as clean air zone. where they have drawn a geographical boundary of the city. In case of Bradford, that is more in and around the city center, a good chunk of it, where they put the ANPR, automatic number plate recognition cameras, so that they can monitor the vehicles which are entering into this clean air zone. And what the government is giving is the incentive to improve the vehicles, especially the high polluting vehicles. So there are grants which are available, has been available for them to change the commercial vehicles. And failing to do that, there would be daily charges for non-compliant vehicles entering into clean air zone. So this is the intervention Bradford is bringing. There are other types of interventions planned in different part of UK as well. So there are different type of clean air zone as well. This one mainly focuses on the commercial vehicles. Okay, and the hope is that, and there is science obviously behind that, by bringing this sort of intervention and forcing the businesses to and supporting them to improve, the vehicles to be low polluting vehicles such as hybrid vehicles, the air pollution will go down and air quality will improve. As I said, Bradford has a particular focus in terms of reducing air pollution because of the kind of health problems we have in the city. We have 1 in 5 Bradford children already have a breathing problem, so people with respiratory conditions. And we have a sort of an organization called Born in Bradford, which is a health research organization which leads one of the largest research studies in the world. And they develop policy and practices for better health in Bradford, and they listed 10 points. And number 1 was reducing air pollution, and also talking about having access to more green spaces and healthy environment as well, and to have research supporting that. So there is a lot of focus on reducing air pollution. So the clean air zone is coming in place in spring 2022. So the idea is that with clean air zone in place and such an intervention being put in place, that should have better outcome in terms of health. It should also impact on health inequalities as well. And also there should be a value for money sort of analysis in terms of this significant investment from the government, providing grants for the businesses to improve their vehicles, but also installing the ANPR cameras and other infrastructure to charge. There should be, comparison for value for money in terms of what it achieves in terms of health outcomes and so on. And that's where I think we are one of the universities or research organizations working with Bradford City Council to do that. And one way to do this is, can we measure localized local measurements? Can we take more local measurements to show that the air quality now, before clean air zone was implemented, and then after clean air zone in next year, 2 year, there has been improvement in the air quality. So that required scaling up air quality monitoring in a big way. And when you look at the technology for doing this, what you have in the UK, if you are in the UK, you might be familiar with this sort of green boxes in and around particular towns, where this is installed by DEFRA, which is an environment agency here, to monitor different gases in the air, but also particulate matter as well. But they cost a lot, and there are maintenance costs associated with it, and the problems associated with it as well. So they are not something you can use for scaling up. So what you have to look at is a cheaper technology for doing this. And also look at something like citizen science in collaboration with technology. So if you're not familiar with citizen science, it's more to do with involving citizens in science projects in collaboration with researchers and professionals. And what you're doing is you have three things you need for a citizen science projects. One is your methodology and principles. This is something is done for last 50 years. So there are good set of principles. If you want to, you can look at European Citizen Science Association's 10 principles. That's an excellent place to start. But also you can have different methodologies as well, which involves citizens in a variety of ways. It could be, level one, which is crowdsourcing, where the citizens are just there as a data providers. They are there as a citizens human census. But it could be also level 4, where it could be, extreme citizen science, where it's quite more collaborative, where you involve citizens from word go in defining what needs to be monitored, what needs to be done, what data comes out of it, the data collection and analysis as well. And what you need ultimately is the technology support, and I'll come to that, how that can be provided by IoT. And then you could conduct citizen science trials, which should lead to open data, because involvement of the citizen and the engagement of citizens is extremely important to keep this project successful. And having open data where citizens can see the data which is produced with their help is extremely important. And this is one of the principles of ECSA as well, principle number 7, to have open data at the end. Okay, so in terms of technology, you can't use those green boxes. They are quite expensive, very expensive to install, but also maintain and so on. You need something which could be low cost. So you're talking about a few £100. UK pounds is when I say low cost. But there is a challenge there as well, which we call research challenge, is that often low cost sensors, which you can find for anything nowadays in the market, you can find for measuring any parameters, often is related to or equated to low quality as well. And when you start using this sort of sensor, especially with the citizens and also with councils and governments, then if it has low quality or there is not reliable quality, then data could be taken out of context, or they would just ignore it because there will be trust issues with it. And there is a lot of research which goes into this over the years. A lot of it looks at how can we use this data as a referential or indicative or informative. So you might look at the trend of data rather than the absolute values. But you can also do something more proactively. So you can have a quality assurance to correct the data which is coming, for example, using calibration. This is the route we have taken in our work and our research. If you're interested to know what sensors we are using, low-cost sensors, which we have calibrated, and I'll talk about how we have calibrated using data science in a minute. But these are the sensors we are using. In our kit, we have Raspberry Pi and the sensors for monitoring temperature, humidity, but also things like CO, NO2, VOC, and so on. But main thing which is calibrated in this kit is PM 2.5 and PM10, and that's the SDS011 sensor. So how did we do it? What we did was we worked with two sort of reference nodes, which are high quality measurement devices. One is from the DEFRA's Air Quality Monitoring Station in Bradford, the one you see in the bottom. So these are the other two sensors which are co-located, these sensors in this pipe. And then we also co-located it with Urban Flows Observatory from Sheffield University, another high quality data device for PM 2.5 and PM 10. And we, as I said, we calibrated the SDS011 for PM 2.5 and PM 10, but also used the meteorological parameters such as temperature and humidity. And there's a lot of detail in the publication we have in the Sensors Journal. I'm going to cover them briefly in terms of how we did the calibration in next few slides. But for more detail, please look at this particular publication. How did we do it? So we used a data-driven approach. There is a lot of talk of, because these sensors are sensitive to temperature and humidity. and two types of humidity, absolute humidity and relative humidity. So we have taken that into account in our approach, and we use number of machine learning techniques, such as multilinear regression. So you have a regression line in this plot, and these are the different data points. And the bottom you have the table which gives you the result of the model and different error rates, starting from R square, RMSE to mean absolute error as well. I'll come to this table and which model performs better. So then we also have used multi-layer perceptron and analyzed result there. So this is obviously artificial neural network. In terms of its input layer, we have 4 parameters there as input. We have the PM values, which are coming from the reference nodes, PM values coming as a row from our sensor, then temperature and humidity, and the output is the calibrated value. And MLP performed slightly better than MLR. We also have used a convolution neural network, again using the same 4 parameters as before with MLP, and having a calibrated value as an output. And in terms of number of epochs we have used, as well as number of layers we have used, all those details are there. Nitty-gritty details are in the paper. And last but not least, we use random forest as well with the configuration of trees to be 20, which, you know, in our comparison, it performed the best. So it had the higher value for R square, which is good, and lower values for RMSE and MAE overall, for both for PM 2.5 and PM 10. And this is what we have used in our devices for calibration. Okay. So I think having as I said, for citizen science, a technology support is very important, but also it's very important for us because we have about 25 plus devices, and we wanted to be very strategic about where we deploy these devices. So we've been very systematic about this. So this is a diagram which shows the clean air zone where it's located, and what we have done is, in terms of choosing the locations where we deploy in the district, we've been strategic. As I've said, we wanted a good representation in our sample in terms of where we deploy. So we looked at the modeling which Council has done, which shows what is the nitrogen dioxide values annual mean at the moment and how they expect it to evolve in next few years. So we have selected the locations which, you know, with some locations which has low values and some which has got very high values to see, you know, how it fares. But also we looked at the distance from the clean air zone is roughly here. So we looked at the distance from the clean air zone as well to see the impact of you know, implementation of clean air zone as well. So we have, you know, from something which is very much in the clean air zone to something which is 3 kilometers away from clean air zone. So that's how we distributed our devices. While doing this, we also looked at the deprivation of the areas as well. So we used something called IMD, which is Index of Multiple Deprivation, and looking at various areas which has different IMD rank, and IMD rank looks at about 9 domains, including income, employment, education, health, and crime, and so on. So the other strategy for deployment, in addition to, you know, choosing those areas to deploy, mainly they are schools, but also citizens. The other strategy was, part of the life critical project was to deploy around park. And we have wonderful parks, beautiful parks in Bradford. This is a map of it. And the park we have selected as part of the life critical project to deploy some of those devices around the park is Horton Park, which, if you're familiar with Bradford, it's near Great Horton Road, not very far from the city center. It is quite green, as you can see, quite beautiful, and a really good park. but it also has very busy junctions around it as well, which are high traffic areas. So this was a good park to select for one of those reasons. So this is same park with a Google Map view of it. And this is another view of it, the same park. And what we have done is we have deployed 10 outdoor air quality sensors. And you can see that this is what I was talking about. These red bits are the roads and junctions, which shows, the modeling shows that there is a heavy traffic there. So this red circle shows, covering those junctions, but also some of those devices we have deployed are inside the park to see the difference between something which is at the junction and something which is in the sort of park as well. In addition to that, this black circle shows where we've deployed indoor air quality monitoring devices in citizens' homes as well, so that we can do comparative analysis as well. This is the team which is working hard to deploy. So we also had to deploy LoRaWAN gateway as well for internet connectivity as well. So all of these are LoRaWAN devices. This is a replication of what was done in Dordrecht as well. So Dordrecht had deployed the devices in their park in Netherlands with the partners IMEC as well. Briefly, this is the system architecture. Basically, we use LoRaWAN and Things Network to collect the data, send it to our service, and then we store and we visualize the data. And this data is available from our what we call Bradford Urban Observatory through the website called smartbradford.uk. You can go and see it, but I'm going to just show you very briefly as well how the Urban Observatory looks like. You can so this is how it looks like. This is obviously the map of Bradford. You can go and see this little markers, which shows the sensors we have, and it only shows you outdoor sensors in the map. You can zoom in, zoom out, and select a sensor you are interested in. So this shows the Horton Park. That's why there are many. It's quite dense in terms of number of sensors we have there. As you can see, Horton Park. You can select a sensor by clicking on it. That fills in your form, and you can select the pollutant you're interested in. And then you can also say, whether you want it for a day or a month or so on. And it shows you a data in a graphical format, which is almost real time. So the sensors are sending data every 15 minutes, and it's displayed in these graphs in real time. So this was taken in November. So this is a week's data in November for this particular sensor, and you can click on the pic and see the exact time the reading was taken and what were the values. And you can already see some of the pics. Remember the WHO limit is 10 microgram per meter cube, and we already see in this little experiment some of the high pics. So just coming to how this helps with the evaluation of clean air zone and how it fits into the bigger picture and the context. As I said, we have about 36 sensors, 10 indoor and 26 outdoor. A lot of them more, in terms of outdoor sensors, majority of them are at the roadside, which is quite helpful. And they are giving us 96 readings per day per sensor. So that's 2,500 readings per day. And if everything works fine, it gives us 1 million readings in a year. And these are quite, in different localities, giving very localized readings every 15 minutes of the day. So how can this, remember I talked about clean air zone evaluation, how it can potentially in coming years can help with that. We already started seeing that through the initial data we have. We have baseline data. Clean air zone is not in place at the moment, but we've been collecting the data for last few months. So I'm just going to show you an example of how this data is helpful to analyze. So this is, as I said, this is the Horton Park, that green park. We have a sensor HP10, which is quite close to the park, and we have HP06, and there is another one there as well, HP06, which is near the park, but at a very, very busy junction. So we obviously can, look at the data which is coming. So this is the roadside HP06. And you can look at the raw data in real time. So this is showing you, different peaks as well. And you can see that, WHO limit is 10 microgram per meter cube annually, and UK limit is 25. And you can see a lot of time it exceeds that. The biggest peak we had was 200 plus. During the bonfire night on November 5th night, November 6th early morning. And that was picked up by other sensors as well, with having a peak of 76 to 200, which is 10 times more than the limit UK has. But we also can do this sort of analysis as well. So we can compare what is on the roadside to the near the park, where there is a lot of greenery. And you can see that I think this two are the most striking one. If you look at the morning rush hour, and if you look at the one which is near the park, percentage of reading which exceeding value of 20, remember 25 is the UK annual limit. In terms of the one which is roadside, about 10% of readings are exceeding the value of 20, while there isn't any with HP10, the one which is near the park. Same thing happens with the evening rush hour traffic as well, 10-12% of readings exceeding the value of 20, compared to none for the sensor which is near the park. Again, we can pick these sort of things. We have a school in proximity to a very busy road, Leeds Road in Bradford, and the readings are really not good. As you can see from here, these two lines showing what is the ideal values for in terms of UK limit and WHO limit as well. So I also want to talk about, while we did this, what are the challenges, if it helps anybody interested in this research. There are challenges around selection of locations, and we came up with a systematic way of doing it, but we had to change plans as well, because when you're trying to do this sort of deployment, I think the challenge is the power, because these devices need constant power, and also line of sight in terms of the gateway as well. So you might have to change your plans depending upon the line of sight of gateway, so that it has continuous internet connection. Calibration of devices, we have shown how that could be done, reliably done, with PM 2.5 and PM 10. But something which is a question mark or a research question for us is how frequently they need recalibration. So this is something we are constantly watching out for, when we would have to recalibrate them, these devices. And that's a question mark. It's an unsolved problem. In terms of deployment challenges, as I said, power supply and the overall maintenance. This is not something you can just put up on a lamppost. You need to involve the council, need all the permissions, requires aligning different calendars and so on, and the cost which goes with it as well. So it's not just the cost of the devices. There are other costs in terms of deployment and maintenance with this one as well. We also have, surprisingly, issue of vandalism as well. So this is, the ideal height to deploy these devices is about 6 meters. And as you can see, somebody climbed that much up, I don't know how, and destroyed one of our devices. I think people suspect that this is some sort of, camera monitoring or something else is going on, even though there are stickers on the device, stating the purpose of it. And as I said, ongoing maintenance of devices and upkeep is a big challenge. We have big ambitions with this work. We want to expand the network of devices and scale, go beyond 50 plus, and want to involve community. Some of the devices are community hosted, but we want to involve a lot more the citizens and the community in terms of hosting. We want to bring in more parameters such as traffic, flooding, water quality, noise, etc. And we want to focus more into the data. All the data shown in the Urban Observatory is open source, right? So citizens can go and download the data. But we want to think about more structured format as well in terms of the data formats for this data. And involve more community, including schools in this. So I think, let me see the time. If I think I have 5 minutes, right? I can go for 5 more minutes. Is that okay?
Yes, sir.
Okay, thank you. So so that's more to do with ambient air quality monitoring and how we're working with council and the kind of research we are doing in terms of calibration and analytics, and how that helps with, hopefully will help with the evaluation of clean air zone, how it evolves in next few years in terms of air pollution. But we're also doing 2 studies on indoor air quality monitoring as well. And what the kind of overarching aim of this is, can we bring behavioral change, positive change in people's behavior. So they do different activities, or they do activities very differently in home, so that there is a better air quality indoors as well. One of these studies doesn't look at any health condition. The second study looks at respiratory condition, asthma, in doing this. Okay, so I'm just going to briefly present. This is a work in progress. Again, when we talked about outdoor air pollution and what are the sources, when it comes to indoor air pollution, what causes indoor air pollution is such as cooking, smoking, poor ventilation, wood burning, even painted rooms, pet and scented items, and so on. So we have a kind of a parallel similar device to outdoor device, which looks a bit more nicer for indoor air quality monitoring. It has same sort of sensors for PM 2.5 and PM 10. So in terms of what it has under the hood is not much or at all different. And it has same sort of calibration as well. So what we have done is, these are the 10 households we have involved, and we prepared the initial questionnaires to identify health issues. In the sample, we have the kind of activities they do. For example, how many times they open the windows or vacuum the house, and so on. All those activities which has positive or negative impact on air quality. We also looked at building characteristics. The type of house when it was built. I also looked at socioeconomic factors as well in this. And what these participants have done is they could log in and they can do a daily diary of the activities they do. But at the same time, what we have given them is a visualization of the data from their devices, the device which is in their home. And we show them what has been the air quality like today. So this blue line shows the air quality today, and what is the WHO and UK limit. And also we show what was it against last week and yesterday as well. So give them a bit more control in terms of the data. Following that, they fill in the diary of what they have been doing, and as I said, the positive and negative activities which have impact on air quality. And we've done the initial analysis of data. So we have a very good representation in terms of ethnicity, education, income levels in this. And we started seeing some patterns in terms of when the air quality is poorer, and what are the timings. So this is some initial charts from that. But more importantly, what we wanted to do is, if we show this data, okay, nothing else, we just show the data. That's the only intervention we do. Is that making any positive behavioral change or not? So if we focus on one indoor activity, which is opening of windows, what we have done is, from the first month to the second month, we have seen a really good change in terms of positive change in terms of people opening it more often and longer, especially at the time when they are cooking or doing the activities which causes pollution. And also we've seen this positive change in the data as well. So this blue line is the pollution before, in the first month, and the orangish line shows the air pollution in the second month, and there is a reduction in pollution and improvement in air quality in this houses. Also, we have picked up positive behavioral change in the qualitative interviews we have done with the participants, in terms of, you know, them being aware of and aware of, you know, what sort of improving the cooking style, in terms of, you know, use of products, in terms of cleaning the house, use of windows and exhaust more regularly, and also raising awareness in terms of them sharing this experience with their, you know, family or friends as well. So we started seeing this positive behavioral change just by showing the data. This is obviously, you know, more analysis to come. This is work in progress where we're writing a paper on this. And we are expanding this work by bringing more targeted behavioral change. So what I call the kind of behavioral change we have seen is more accidental, so and limited with limited intervention. So only thing we have shown is the data, but can we do more targeted behavioral change? And we're looking at working with psychologists in terms of using a very popular behavioral change model called COMBI, to bring in more intervention, targeted interventions, to see more targeted behavioral change as well. And we are applying the same thing with, as I said, with asthmatic patients, and helping the clinicians in terms of their self-care, you know, by doing something similar with them in terms of providing these devices and giving access to the data and the support in terms of what they can do in terms of improving indoor air quality as well. Okay, so I'm almost at the end, not bad in terms of timing, hopefully. So I just want to, you know, have this slide with, you know, people who have contributed and helped with this work, you know, from Bradford City Council, but also from citizen groups such as Friends of Horton Park, our collaborator, August Watney from Swedish Environmental Research Institute, Eva from JSP, and Sagnik from IIT Delhi. And these are the schools which helped us to deploy these devices in Bradford. Thank you very much.
Thank you very much, Dr. Dhaval. This has been a very interesting talk that you presented. In fact, one of the most impactful research that you know, you talked about, because today world over we are suffering because one of this environmental pollution is one of the most important things that we're all suffering from. And interestingly, not many countries nor governments are actually paying heed you know, to the depth of the study that you've done. So I guess this is going to be a very impactful and a very important contribution, you know, globally as well for the studies that you've done. Thank you, Dr. Dhaval, for making this change and contributing to this cause. Yogesh sir, welcome to the session, sir. Thank you very much for joining in. I know you were busy and you have a very, demanding schedule. So hence, thank you for pitching in. Thank you for coming in, sir. Your thoughts on today's session?
Yeah, thank you so much. I'm so sorry I got a little late before. Can you hear me?
Yes, a bit low, sir. Yes, can hear you now. Yes.
So sorry I got a little late, Dhaval, joining before we start. Really interesting work, obviously, very applied and very relevant for today's context. I just have two very minor queries rather than, you know, any concern, but two minor queries. What are the challenges that one may face when they involve citizens into such projects? I mean, you know, it's quite, when you do things between researchers, it's quite easy, controlled. But when you involve citizens, obviously it's beyond your boundaries. So what are the challenges that you may face? And second query is how these findings, obviously very important findings or insights that you get from the continuous observations and analysis, how this actually informing policy at all? And if not, then what can be done actually to inform them to do something about, obviously. So these two things. Thank you.
Thank you, Yogesh, and nice to see you. I think the first one is a very interesting one. I think that doing citizen science is extremely challenging, involving citizens in a project like this. You would have two types of people who are extremely interested. You know, air quality is a topic which is let's just say very charged topic. You know, some people get really angry about things, and some people are not that bothered. So I think the engagement is extremely important and also extremely challenging as well. So kind of problems we have encountered is when you ask people to do the diaries or look at the data, it doesn't happen always. Okay, and that would be, anybody who does citizen science will tell you that, you know, daily diary is not something you should go with. So involving them in the science itself is difficult. And I think that is, you know, there are ways you can improve that. And one of them I talked about is, you know, if you do co-creation, an extreme level of citizen science where you involve them from word go. So they are part of the solution development. So they are co-producer of the solutions. That could go a long way in answering this question, answering this problem, I think. The other engagement challenge we have is, you know, use of this platform. So we have this beautiful platform, you know, 30, 40 sensors, you know, a lot of data comes out of it, you know, use of it is very limited, right? In terms of the citizens. Okay, so there are a lot of citizen groups trying to improve the air quality. They could use this to see whether the kind of interventions they are bringing in is making any difference or not. But involving them to use this sort of platform is a challenge. We also never find out what is the context. Okay, so mostly this pollution is from vehicles, but a lot of times we have peaks which are, you know, 1 o'clock in the night, and we believe that's due to the wood stoves being used. As you know, probably in Yogesh and others, you know, who know UK context, the wood stove is something which is used for heating. You know, in the current context, it's even more important. You know, people who are well off use it because it's quite nice and fancy thing to do, but people who are not well off use it because that's cheaper than other alternatives as well. So we have this, you know, a lot of time we get these peaks which are extremely odd, 1 o'clock, 3 o'clock in the night, and that is, we believe, due to you know, burning of woods for heating and hot water. And I think, you know, that sort of thing would be nice to involve citizens to know the context. They know their area, they know what's happening, you know. So I think that is the challenge. The second question in terms of policy making, I think this sort of work nowadays is feeding into policy. I think governments are more, you know, understanding of you know, that this is a problem. It needs to be solved. Although, as I said, UK's you know, guideline or the limit they have set up is fairly relaxed compared to what WHO guidelines are. You know, you know, WHO is 10, while UK is 25, which is more than double. So it's quite fairly relaxed, I think. But I think this is slowly, this sort of work is feeding into this. And I think we have a role to play as independent organizations, research institutes, to be part of this sort of monitoring. So some of the work we are doing, but also we have a sister organization called BIB, born in Bradford, which is doing a lot of work in terms of monitoring the health. So they're going to monitor the health before the clean air zone has come into place, and it would be after as well. And I think this would be an interesting exercise in next 3 to 4 years for other cities to, you know, emulate and follow, and the public policymakers to take this on board. Yeah. Thank you.
Thank you so much, Dhaval. Sorry, Santosh, just one other thing. Obviously, I know you've been working on these kind of things for last 10 years, perhaps, Dhaval, in various projects. And mostly these are kind of, you know, you using technologies to kind of monitor these effects. Is there anything you thinking of or you doing which actually can help prevent? So using AI or IoT or any other technology that might be emerging can actually help prevent some of these problems. Is there something you're thinking of or doing, or is something not feasible at this moment?
I think we haven't been thinking of, to be honest. We are sort of more focused on monitoring. I think because this is, I think a lot of this problem comes because there is no awareness, right? And there is no data. You might think, I showed you the park, right? Such a beautiful green park. If you are around that park, you wouldn't think. But I also showed you how bad it is, in terms of just outside, less than 100 meters away, 50 meters away, how bad it is. I think for me, what excites me is how do I bring this data to citizens? How do I involve them? And that kind of leads to the change, I think. The other kind of intervention is what, council is doing, that's, sort of, improving the vehicles and so on, I think. I think there is a lot of mileage in bringing data to the citizens and helping them to self-manage this. Yeah.
Thank you, Dhaval. I mean, it's very interesting and very relevant work, as I said. I mean, most of the people talking about at the moment, climate change and all these kind of things, and very little actually done practically. So you are doing practically something to provide data, to provide evidence, and then perhaps the changes can happen. So thank you so much, Santoshi. Over to you.
Thank you, Yogesh sir. Dr. Dhaval, I had a query. In fact, I was thinking along with the way that you were presenting. I was very engrossed in your talk, and one of the things that came to my mind is in a country like India, in a developing economy like India, with varied kinds of topography. How would the citizen monitoring scale work? Would there be any changes required in the system because of the sensors, the kind of equipment that is required, and also the citizen, the CAZ that that you proposed on implementing? So clean air zone, instead of punitive measures of 60 pounds and so on and so forth, would a reward mechanism work better? Have you studied something on that? If so, please share your thoughts on that as well.
Yeah, sure. I think the first part of the question, I think in terms of the technology, I think India is very well placed to use this technology, and people are using this, low cost devices, calibrating it, using citizens for deployment and so on. I think there is nothing so innovative about the technology itself. Is the use and how you use it, and how you use it in policy and so on, is where the novelty is. It just needs internet connection, and India, it is perfectly placed. In terms of you talked about rewards. I think it's both. Even you look at the clean air zone. I hope I mentioned that it's not punitive only, or it's not punitive at all. Correct. It's more rewarding because the government has pumped in a lot of money to support the businesses to change the vehicles. Correct. These are the only vehicles which are not changed are charged to enter the clean air zone. I think there is a lot of grant which is available and will be available for the vehicles to be changed. So I think it's both. I think for me, I think the thing which works is something which hits the pocket, I think, when it comes to something like that. But it cannot be just citizens bearing the brunt. I think there has to be right incentives from the government as well to help with that. It should not be only citizens. Yeah.
Absolutely. Thank you very much for those inputs, sir. And we have Professor Daniel Migu, who's gone ahead and expressed his thanks to the organizer, to you as well, the speaker, and he's moving on to his meeting, to his next meeting. There is a query coming in from Rupal Bed, and her question is: what were the interventions that were implemented which resulted in the improvement in behavior of citizens towards indoor air pollution?
Thank you. Thank you, Dhaval. If you can write in chat as well, where are you from, and also, you know, which institute and what background you have, it will help to contextualize the answer as well. But I think we didn't have, only intervention we had was the data. Okay, so we showed them the data from today in terms of what sort of pollution is there, and compared it against WHO and UK limit. Although there aren't any limits in terms of indoor pollution when it comes to UK and WHO, they only talk about outdoor. But we showed that as a comparative analysis, and also showed them the data from the week before and yesterday as well. So there was no other intervention. So just by showing that. So this is why I say accidental behavioral change. It was very little intervention. The next time when we do this, the other study we are doing with the Combi model, we are bringing a bit more interventions and more targeted interventions, as I said. But I think what we've observed from qualitative data is that they themselves looked up you know, information on air quality, indoor air quality, how it could be improved. So they did their own research as well. This came out from our interviews when they looked at this data, especially when the numbers were high. Yeah, thank you.
Thank you, sir. Thank you, Dr. Dhaval.
I think so, has meeting at 2 o'clock, so we already, you know, little late, so
yes.
we can close now. Yeah,
absolutely. Yes. So with this, sir, we'll close the session for today. And thank you very much for your time and your contribution towards society, and you know, helping us all understand your work as well. Thank you, Dr. Dhaval, for your time. Thank you, Yogesh, sir, for your support as always. And looking forward for the next set of seminars as well. So all the best, and thank you all. Thank you to all the participants who've taken out time and joined in. Thank you all.
Thank you so much, Dhaval. Thank you so much for your valuable time.
Thank you, Yogesh. Thank you, Santosh. Thanks, everyone.
Thank you so much. Bye.